So now we can begin with most of the work here. So before starting off, I'd just like to create a new class called a vector. And what this class will be, it will essentially just be a class that manages all of the operations done on a vector. And what this will do is it will simplify the process required in calculating certain interactions between other objects. So we'll create a class again, except this time we won't create a new one. We will just export the class itself instead of calling a new one like over here. This is because we want to create new vectors as we go, and we don't need one for the entire project. So with the constructor class, we're going to start off with an object that describes its x and y. Actually, what I'll do, I'll just do this. I think it will be much simpler. Now this dot x equals x, this dot y equals y. And so we have a vector. Now we could do many operations on this vector that are needed in the interactions. And so the first operation that I'd like to talk about is the addition of another vector. And essentially, the addition of one vector onto another is adding their coordinates onto each other. So we add both the x coordinates, and then we add both the y coordinates. Now subtraction is pretty similar, except what we're going to be doing in this case is obviously we're going to be subtracting. We can also multiply by a scalar. And this process is simply just multiplying the coordinates by the scalar value. Similarly, we could also divide. So we'll just replace this, and I did this on Mac. I believe it's Option and then click, and you can just have multiple cursors like that. It allows you to select multiple things like this. And that's the multiplication. One important aspect is also the magnitude. And I could make this a getter, but I'm just going to keep it as a function just for simplicity's sake. This will return the square root of the sum of the x and y coordinates squared. There you go. Another important aspect is the unit vector. And the unit vector is essentially the direction of the vector while also having a magnitude of 1. So return this dot divide, this dot magnitude. So the magnitude of a unit vector will always be 1, but it would also indicate the direction of where the vector is heading. And I'll explain this in a sec. What we also want to do is if this dot magnitude equals 0, then just return a new vector or a new 0 vector. There you go. We also need the normal, which is essentially just a vector 90 degrees to the right or left of this vector. And the process in doing this is create a new vector. We swap the x and y positions, and for the x position of the new vector that's being produced, we just multiply it by 1, by negative 1. You also need the dot product of a vector with another vector, and we get this by adding the coordinates of both vectors multiplied by each other. So something like this. Lastly, I also want to add another function that draws this vector onto the canvas. And the first two parameters will be the position that it will be drawn at. Secondly, it will also be the color. And let's just set a default as black. We can also have a factor, which will in default be 1, but you can multiply the length of the vector by the factor. And so before starting, let's just import the canvas. There you go. And since we defined the canvas, or predefined it here, we get the actual canvas instead of the class that creates the constructor class. So what we could do here is just canvas ctx.begin path as we did before. Except here we position it. Oops. And then we draw the line depending on the vector that we currently have. So line 2, this line 2 position plus this dot x, position this dot y. There you go. And as an adder, we're also going to multiply by the factor, just so that we can factor out, we can multiply the length if we need to. We can also set the color as color. And finally, we have to actually draw it, which is done through the stroke method. And so we have all of this right here, and you're going to notice a problem in a sec, but I'd just like to show this to you. So let's create a new vector. And this vector will point 100 pixels in the positive x direction and 100 pixels in the positive y direction. Now let's draw this vector. So v1.draw. Let's place the vector in the center of the screen. So canvas.element.client width divided by 2. Canvas.elements.client height divided by 2. And the color, let's put the color as red for now. And I believe that is the case. And as you can see over here, the vector actually points in the negative y direction. And in this case, the reason why this is happening is because Canvas actually reads the positive y direction as down. And so this may be a problem and may cause a bit of confusion later on. And what I'd like to do here is I'm going to create a method onto the canvas, and it'll be called toCanvasY. I'll have the y value, and it'll essentially just return this dot canvas dot elements dot client height minus y. And this will essentially just reverse the direction. So, and back on our vector class, we can just wrap this around canvas dot toCanvasY. And there you go. And so now let's test the addition, subtraction, and multiplication. So let's just create a bunch of these. Vector 2 will be 50, it'll also be 50. And vector 3 will be the addition, v1.add v2. And so let's draw both of these, and then also the third one. Whoops. And you can see, actually let's make it a bit more clear. Let's put the y value as 0. And so as you can see, let's just make it a bit more clear. The v1 is red, v2 is blue, and v3 will be green. And so I've drawn all of these vectors, and that does not seem to be correct. Let's check over here, and of course, a silly mistake. It's supposed to be subtract. So there you go. So if we just put this end, the left end of this vector onto this one, it's going to create the vector 3. And so if we subtract them, it brings the previous result, which was what was expected. So there you go. Addition and subtraction now work. Let's check the multiplication. So v1 multiplied by, let's just do 2 times. And I might have made the same mistake here, silly me. And so yeah, there you go. It's double the length of v1. You could also divide, so it'll be half. We could have also just kept that multiply and just did 1 over, but I think it's a bit more clean to have all of the operations.